Next, you learn this one called as copy problem. What is copy problem? Why we get this one occurred? In terms of copying, there is something called as shallow copy, deep copy, and the assignment. I have like detailed video also for that, but generally to speak again, generally when you are working with immutable objects like basic data types like int, float, string, boolean, or like tuples, there you don't find this problem. Only for the mutable objects you will find this problem. To understand this clearly, if you see in this example, I have taken a number 1 equal to 123 and I am now changing number 2 equal to number 1. Like I'm not. Pardon? Fine. So number 1 equal to 123 again. For number 2, instead of assigning directly, I am assigning from another variable. Did you see? Will it make any difference? No. So, but you both will get the same value. Now, if you see that address locations and the values together in one shot, you will understand. When I assign the first value with some value, did you see that first one is 123 integer? You got some address location. In the same fashion, if I go for the next one, number 2 is equal to number 1. I assigned with another variable, but did you see that as I assigned from another variable, both got the same address location? Fine. Now for number 2, I am changing the value to 999. So as number 2 was changed, is number 1 affected or not is the question. When I changed number 2 is equal to 999, only number 2 was changed. Number 1 is like 123 only. Means if you are not defining directly, but assigning a variable to another variable, there is no problem at all in what is that? Immutable objects. But if you do the same thing in a mutable object, that will cause a lot of issue. Means if I take like one object, say like pair list or like parent list, for us to better remember. I took like, I'm asking it address location and the value it will tell. Now I am doing like a hard coded list where I'm doing like an assignment operator, right? Now observe the difference. Using assignment operator, I assign. So instead of creating a new object, both will refer to the same object. So same sir, here also same address, same address. In fact, here also in the same way it happened, right? But when you assigned, it didn't show any problem. But for the mutable objects, it's not like that. If I say like, in the parent list, if I ask for the second value, it will tell what is the second value. And if on top of it, if I'm trying to update this second value, this is a typical substitution operation. So when you make changes to your parent list, only that should be affected, not your hard-coded list. So, but did you observe that when you make the changes, your parent list is updated? That is fine. But if I try to check my hard-coded list, that is where the problem comes. If you observe here, did you see that 1111 was changed to 3333 in both the cases, both in your parent list and hard copied list? This is the problem. So this will happen only in the mutable objects. Sir, how to avoid this kind of problem means there is a module called as copy. Using that copy, you can create like some copy of that list. Whenever you want to take a backup, so you do it. Just imagine like if you have one chemical, if you want to do multiple tests, you take like one sample and from that sample you take small things and you do different tests, right? When you're doing one test, it should not affect the original sample, right? In the same fashion like this, you need to create like a copy. So you can create a copy in multiple ways, but this is the simplest and best way. Copy.copy is the worst way. If I do like a copy.copy and if I execute the same thing, so from the same pair list, I'm creating it. And did you observe that the address location is same in all these cases, but in the soft copy list or like shallow copy list, Did you see that what happened? The address location is different. But sir, this change is there means we created after this change, right? From here you created. Let's see what will happen. Now, within the hard copied list, if I want to change something, that should not affect the soft copied value or shallow copy. So you have hard copied list. Within that, I'm asking second value 0, 1, 2. So now second value is 3333. If I do like a 4, when I make changes to the soft copied list, as you know the problem, thus hard copied list and the parent list both will be affected, but not the soft copied list. Did you observe? These two are affected, but the third one is not getting affected. It is giving a different address location and others. Now, did you see we solved this problem? Fine. Now, okay, sir, this is what shallow copy. Now, I want to prove the other way side also. Means in the original list, if you change, it should not affect. In the same fashion, in the shallow copied list, if you make changes also, it should not affect the other one. So in the shallow copied list, I am changing the 0th value, which is like 11 to 0. Then it should not affect the other two. Did you see that in shallow copy, if I make a change, did you see the other two were not affected? That is the point. So like this, we can create a safe copy. This is good. But there is one more problem to understand. Then what is the point of going for something called as a deep copy? So deep copy, I will tell you. Say I have like a list. Till now I have a small list which is a single dimension. But what if I have a multiple dimension list? Let me show this in an interactive mode for you to better understand. If I take right now like a like this list like this, I'm creating three things. Okay, I need to create. So first I need to import the copy module. So, and we need to create like this. I created a new list, soft copied list, new deep copy list. Like that, three things were there. Now, if I ask the values of it, so if I ask what are the values are there, did you see values will be same because from the same thing you are creating. But did you see the address location is different for all these three? Same like copy.copy, I used copy.deepcopy. Now, sir, what will happen? If I go for like say value within the inner dimension. So for a single dimension, things were fine. But if I go for like this, if I go for the new list, mean the original list of 2 of 1 means way within it 0, 1. This is entirely 2. Within this 2, if you want to say 0, 1, this is 2. And within that you have 0, 1. This is 4, 4, 1. You want to change this value. But when you did a change, did you observe that even the soft copy list is having some kind of leakage? So that is the conclusion I want to draw. Means generally we want to create a, so to conclude what are the problems we solved. For immutables, if you are referring from the one object and assigning to another, there will not be any problem. But if you are doing the same thing for mutable objects, there will be a problem. To address that problem, there are two things. One is shallow copy or like other one is deep copy. Shallow copy is suitable for a single dimension. But if you have multiple dimension objects, so then shallow copy will also have some kind of leakage for inner dimensions. So when you have multiple dimensions, go for deep copy. When you have a single dimension, go for a soft copy. So this is what all the learning that we have made. So similarly, I want to bring to your notice one more interesting point that, so yeah, this is what the conclusions we have drawn, right? That I want to mention. So shallow or soft copy, so is faster. So, but it cannot work for the only one dimension only. So, but if you are going further, you should go for the other one. In the same fashion, if you want to create this kind of shallow copy, that is not the only way. Means copy.copy is one way you can create. In the same fashion, you can use, let's say I created a small list. From that, if I want to create a copy, I can do like this also, of colon or colon colon, like that if I give. In that way also it will create a shallow copy. So in fact, I wrote the entire explanation for you to better understand here so that you can follow that. You see here, I wrote it everything. So if you create like a shallow copy, both will have different address locations. When you make changes to one of them, the others will not be affected. You can do like a single colon or two colons, either way. Or not only that, there is also something called as copy attribute. You can use like dot copy also. Copy is another attribute we can use for copying. So like that, we can create all kinds of copies. So now it is clear what is like copy, shallow copy, so and deep copy and others. Now, based upon this understanding, and you understood by now like the entire attributes of list. So with this understanding, you need to implement a stack mechanism. You need to take a list. So you need to do like a stack. Stack means a simple example is like a CD tray, or like let's say simple example. You have a tiffin box. In your tiffin box, your mother will cook like some chapatis and place it. So whichever the chapati she placed first, you will take it in the last, because so that is how we need to go, right? So means first in, so last in, first out. Whichever she placed last, that you will eat first, right? So this mechanism is called as LIFO, or last in, first out. So in for the stack to be adding the values, that concept is called as push. For removing element is called as pop. And to check the status means like it gives the stack size. So you need to implement these three operations on your stack. For that, the hints are like pop, append, and list. Similarly, you can implement the queue mechanism, where first in, first out. Queues are nothing new for like Indians. Wherever you go, there is a queue. So whoever goes first, so they will take the things first. Whoever go next, they will take the things next. So same like here also, push pop is there and status is there. But here for pushing, you can use insert. For removing, you can use pop, and you can use a length for the status. So hope this is a good assignment for you to walk through and working. And the last problem with so this is like referencing issues. So you need to be very careful, especially when production codes. Referencing issues means I will quickly walk through. If you have some list, let me place it everything here so that you will understand. If you have some list, from that list, if you are taking, let's say I placed a clear, my list is so and so. And for this list, if you are assigning directly, you get like one value. If I ask like, hey, what is my list? Oh, sorry, clear. My list one is equal to, if I give empty like this, if I ask, hey, what is my list one, you get empty. But if the same my list one, if you are assigning like this, empty into 3, generally, till now string repetition, so list repetition and others. Now, if you see this same thing, my list one, did you get like it is empty again? But if I give like the same list of say 1 into 3 times, if I ask, if I say my list of 1, did you see that same 1 is coming 3 times? That is also fine. But if I go one step ahead, and if I tell like a list of empty lists, if I ask like for the same thing again a multi list, you got a list of empty lists. And on top, if I take like list of empty list of 1, so you get like when I ask list of empty lists of ones. So what is the problem, sir? We will get. So there is not a problem. The real problem comes when you are changing these values. So observe carefully. You have these values. There is something called as anti-pattern. Anti-pattern means like this is a pattern which should not be used by anyone. So next you learn about a lot of anti-patterns. This is one anti-pattern. What it is saying is that when you did like a list of lists, as I told, you will get a list of lists. That is fine. But after creating it, if you are adding one of the element or modifying one of the element, did you see the changes will be affected in all these 3? This is also one kind of leakage. So whenever you want to create an empty list, 3 empty lists or 4 empty lists, you should not do like this. Then what is the solution, sir? Rather, we can go for something called as a comprehension. I will tell you what is list comprehension afterwards. But it's a simple like a for loop, but writing in a single line. So this is the best way of doing. So in this way, if you make changes to one, it will not affect the others. And another problem that you need to see is like, you see here, I took like a list of lists and I'm multiplying with a 3. Now the same list will be used for multiple times. So if you make changes to one, it will affect the others also. To avoid that, I told that instead of using a multiplication with an integer, you need to do like this loop and do. So this is another referencing issue that you need to be aware. So with this, we understood about what is the list. So the next big thing is about tuples. Tuple. What is a tuple? So the rules of list and tuple will be the same. Both can be indexed by position only. So you take the values and work with them and do anything. The slight difference between a list and a tuple is that in list, the same values will be stored in the last outside braces as square braces, here with a parenthesis. That is one big difference. That's it. So what does it make that difference? Means in terms of usage. So both were indexed by the position, but for a tuple once created, we cannot change the values. So but length will be same. So length will be same for both. Values will be same. Everything will be same. In terms of usage also, it is slightly different. Let's say I want to create one more tuple. Whenever I'm creating like one more tuple, let's say I'm writing empty print. I want to create like a single value. This is most important point that you need to be aware. For a list, for a single value, there is no problem. But for a tuple, so if you have a single point, say 99.9 I give. Okay. Now, if I ask, hey, what is the length and what is the type if I give? Observe carefully what will happen. When you're asking type, instead of saying that it's a tuple, it is saying float. And when I asked, hey, length, it's saying for float, you cannot get the length. Why, sir? What is the problem? The problem is that, in arithmetic operations, when you do plus, minus, and others, there also we use the same braces. During PEMDAS, you remember I told about PEMDAS. At that time, you understood, right? PEMDAS. You use it the same braces. If you see in your keyboard, we are using almost all braces. There is no new key braces. So they are using the same braces for your arithmetic expressions, also for tuple. How they can differentiate whether it is a tuple or not? So the problem comes only when you have a single value. When there are more than one values, everyone understands it's a tuple. So when you have a single value, you need to write a comma at the end. So this is the most important point you need to remember. If I execute right now, it says it's of type tuple and length is one element. And in the same fashion, if you want to create an empty tuple, so that is very simple. Same like list, you can write like braces, or you can use the tuple built-in function. You can create like a empty tuple. And also the good thing is that if you don't write any braces, that also it will be treated like a tuple only. So this may be interesting for you. So observe that. If you don't give any braces also, it will treat like that. And also, as I told, if you have a single value, you need to write a comma. So if you have a single value without any braces, but you have a comma, then it will treat like a tuple. Single value without comma, then it will not treat like a tuple. Hope you all understood. The usage and creation of tuples you understood. But in terms of attributes of tuple, not like a list, it has a very less number of attributes. So if I go for like DAR of a tuple, you will understand. I have created a tuple of some values. And in terms of usage, you use DAR, right? If I ask DAR, You can see almost all things which have underscores on either side. I already touched, I don't want to touch it further. What are left? Only two things. So, which is count and this one. If you want to understand, as I already told about things which have underscores on either side, I just don't want to touch again, but still briefly to touch it. You can see length, we can work with length built-in function or underscore underscore length, or like strings, str built-in function or underscore underscore str, or tuple repetition. This is something unique. Sir, you told like tuples we cannot change. Yes, we cannot change, but we can multiply with a number. Then what will happen, sir? It will create a new object. It will not touch the original object. So this is possible. If you want to check, you can check that. You can go to the interactive mode and you can create a small tuple and you can make the changes and see. So if I take a tuple, I take it. So if I say, if you want to get the address location, ID is a built-in function, my tuple, you got the values. And for this, if I say my tuple into 3 or 2 or something, you get the same thing repeated multiple times. Fine. And if I ask like again my tuple, did you see the original object is not changed? So that's why any operation which doesn't change the original object were supported. That's why you see all the operations of the list you are getting, but all the objects which may change the values you are not getting. That's why there is no append, extend, insert, nothing, delete, nothing. And similarly, if you want to do equal, we can do equal or underscore underscore equal. Means comparison. You can check like this also. So we have two things. What are that? So count and index. Count and index are same, whatever you see in the list. If you have some values, if you want to check how many values are there, for that only we have count. If you ask like my tuple of count, at the base level, it has only 1 5. It has 1 5 or 2 5s. Okay, this is very interesting. So in this particular tuple, how many 5s are there? Can someone tell? If I ask count of 5, what will be the answer? Yes, can someone tell? So in this tuple, how many 5s are there? So you need to understand here that what is the difference between these two? Did you see that here I didn't place a brace at the end? I have a tuple within a tuple, right? But for in a tuple, there is only one value. I didn't place a comma. Then what it will treat it like? My tuple. Did you see that this is a 5 and this one is also a 5, which is an integer instead of a tuple? But if I place the same thing with a comma at the end, then if you ask, it will treat it like a tuple. So in this case, if I ask what is the count of 5, instead of telling it 1, it will tell 2 5s are there. So that is the difference. Okay. And the next thing, after tuple operations, you can see in terms of tuple operations, what all things that a tuple support, what kind of things we can do with a tuple. If you see, so tuple supports like all operations, but Python is like a strictly typed language. If you want to do operations, all should be of same type, right? If you see here, there were two tuples. This is one tuple, this is another tuple. So we can do it. And here in this case, you see, this is a tuple. You did a plus operation and placed one more brace. So this is interesting. If you try this, you will understand it. So if I have two tuples just added like this, it works, right? But if I remove this brace, it doesn't work. So if I add again, it works. But after this, if I place one more tuple, so one more comma, it changes the entire picture. Did you see what happened? So that's why don't place a comma unnecessarily every time, okay? So if I say just 99, it is an integer. 99 comma, so dot, it will is a floating point value. If I say comma, sorry, comma, it will become a tuple. So that's what you need to understand. See here, you were trying to combine a list and a tuple, so it doesn't work. So you need to convert your list to a tuple using tuple built-in function, or convert your tuple to a list using list built-in function. Similarly, if you have any string, you can convert that to a list or a tuple using these built-in functions. And also I told you, right? Tuple repetition operation works. It will create a new tuple, but it will not. And similarly, the assignments for you is like, check whether tuple concatenation is commutative. So tuple repetition is commutative. Whether these two properties are correct or not, you give a try. So the next thing about the tuples after these operations is immutability. So the most common question like everyone asks about is like, what is the difference between a list and a tuple, or like what is immutability? I told in a great length about what is mutability and immutability. Anything which supports in-place changes is called as a mutable object, whereas tuple doesn't support that. That's why it is immutable. So to understand that, I showed you clearly that if I index a value, I get the word. But if I index and try to update it like a substitution, then it will throw an error. So if I clearly ask Python 04, you see what are the object which may throw error, I wrote in the try block and I handled the exact exception. Did you see I got the exact exception saying that you cannot use it? But the point is like we can overwrite it. So in fact, we can overwrite any object, right? We can just reassign. When you reassign, what happens? The address location is different from the original address location. So that is not a thing. So with this, it is clear that tuple is an immutable object. One last point within the tuples is that, so there is another tuple called as named tuple. This is very interesting. Named tuple means, till now what you know, a tuple can be accessed by the position, right? If I have some values, I can get the values by the position. If I clear the screen, so if I go to the IPython, if I take like some numbers, okay, I have some tuple. If I ask like, hey, tuple of 0, I get it. So tuple of 3, I get it. Tuple of 5, I get it. Means I give a position. In that position, if it has a value, you will get it. But can I get with a name? No, right? So that is the concept of named tuple. Named tuple can be accessed by the index, same like an ordinary tuple. Apart from that, we can also access like a key name. Next, you will see about dictionaries. Like that, we can access this. So means like if I take something called as a some kind of tuple. If I have 3 values, by seeing at it, you understood that there are 3 values. The first one is a name, second one is age, third one is a date of birth. So does it support in both ways of doing is the question. So for that to work with, I will tell you, you see, 0th value, first value, second value. If you straight away ask, you get the values. Okay, at 0th value, first value, second value, like that. But if you want to get them like a position, for each of the thing, you need to give a position. For that, we need to use a collections module. This is another module that we will use. Using collections module, you create like a template first. Okay, 0th position will be name, first position will be this one, the second position will be like this. So I am creating like a template. If you observe, collections.named tuple of, for this template kind of named tuple, you create some name. So most of the time, give the same name here and there, and you give the value positions. So in a list or a tuple, whatever you give, fine. The corresponding positions, the 0th value should be name, first value so and so, second value like that. So it will go in like a template. Now from the template, you need to create the tuple. Instead of just placing the braces, from this tuple you create the thing. Students of, if I give the same things like Santosh 25, if I give a date of birth. Now this one will be accessed in both ways. If I say here for the same object, so previous one we can access only with position, but this one we can access with position At the same time, with respect to their names, for that position, if you give a name, you can ask with that name exactly. So if I clear, so exit, so Python 05, you got it. Did you see by the names also we are able to access? So that is the point. Now, at this juncture, I want to tell you some interesting point. Till now, for many objects, you are using this dot attribute, right? So what is the point of dot attribute means? Whenever you are using a dot attribute, you will use one built-in function called as getAttr. Till now, you never use this built-in function called getAttr. In future also, you don't use it. So these are all built-in functions which will be called in the backend, like a slice or a bull or like getAttr, all these things. But whenever you're doing a dot and asking, it will indirectly do like this. So I told assertions are like correct. Means if you do like student2 dot name or getAttr of student2 comma the name as a string, so both will do the same job. So getAttr, if there is a wrong, it will throw an error, right? If it is not wrong, it will be correct. So this is what I want to tell. So if you want to get an attribute, this is how you get it. But sir, if your particular value is not present and if you're trying to access, it will throw an error, right? Generally in indexing, if you ask for an index which is not present, it will throw index error. But if I ask full name, did I define full name above? No, I didn't define. Then it will throw a attribute error, right? So whenever, if you want to access an attribute, first if you want to check whether that attribute is present or not. So there are two ways. For any object, if you want to check whether an attribute is present or not, you can use the in operator with a dir, because dir will give all the attributes, or we can use the has attr built-in function. For has attr, you pass like the second one as a string. In both ways, we can check. Now, if you don't want to get the exception, you can use the has attr built-in function to access it and check. Does it have an attribute? No. Then you need not do. If it has attribute only, you can get the attribute. So that is how we work with like getAttr and hasAttr were like two separate attributes of functions which we touched in this particular built-in function. Now by this time, if you see almost all the built-in things we have worked, and one simple use case of this name tuples we can see, but like you can check for like multiple use cases will be there. So most common like ordinary tuples if I take by position only, you can do like you do like some operations with respect to that. Say it's a typical operation you are doing. But if you create like a named tuple, so x coordinate and y coordinate, generally coordinating system means you get like this. It's better to refer with this, right? With dot x dot y instead of with the position. Or else sometimes you get like very 10 or 15 values. You don't know what is the 16th value or 15th value, right? So every time it's better to have like this. So instead of dictionaries, named tuples are much better for most of the times. We need to see. And one last point within the tuples, which I forgot, is the unpacking. So till now you understood what is unpacking, but I want to give one more step to this unpacking by helping you. Whenever you have two variables, you are assigning in multiple statements. Instead of that, we can assign in a single way called as unpacking. Unpacking means the number of variables on left side and number of values on right side should be equal. Or right side also you can have another variables, but that should be defined first. But both should be of same length. If I take like one more example, you see I have these many variables and exactly same number of values. Instead of the values, I can have some of them as variables also. Means maybe the last two, I want to tell like number 1, comma number 2. So every time the right side doesn't mean that it should be values only. It can be variables also. But the exact thing should be defined. And two, these variables should be first defined above. So this concept is called as Oh, sorry, it doesn't work like this. You can assign, sorry, this value will be assigned to this value correspondingly. Yeah, this is a possibility. If you see this, it will work. 0, 8, so and so. You see, it is working. And if you have like any much less than that, then it will throw an error. So if you see these examples, if I have 4 variables and 5 values, it will throw error. If I have 6 variables and 4 values or 5 values, it will throw an error. Means if there is a mismatch, it will throw an error. Now, how to handle this problem? So if I tell like, so one variable if I give and all the values if I give, in that case, it will treat it like a tuple. Similarly, if I go for like another case, if I have 2 variables and different number of variables, then also it will throw an error. But sir, sometimes if I don't know how many values are coming, but I want to assign. Now, the same thing I will use with a slight difference. Instead of number 2, I gave an asterisk before it. This is called as variable unpacking. This is something new in Python 3, which is not there in Python 2. Similarly, if I do the same thing else, other side. Sir, I don't want, if you see, observe carefully, the first one is given to the number 1 and remaining all values are coming to the number 2. And if I do a slight difference, if you observe carefully, first one will go to the first one, number 1, last one will go to the last number, and the middle values all will go to the middle one. If I execute right now, did you see? First one is going to the first one, middle ones are going to middle, like this. This is called as a variable unpacking of this one. Hope it's fine. So with this, it is clear. So next, we will learn about the sets in the next class.